Okay, this is the second video that I am recording on the Test L multiple choice non-calculator. So number 4 was a question that was asked, and it wanted you to find the derivative of a quantity to the fifth. So I am going to use the formula 5u to the fourth times u prime. So I have 5, then I have the quantity to the fourth. Now this is the derivative of that quantity, or the derivative of u, which I had to use the quotient rule, v u prime minus u v prime all over v squared. And then they just clean it up, multiply the numerators and denominators. Okay, the next one was number 6. Number 6 wants the slope of the tangent line to the graph of y equals ln of 1 minus x. So I'm going to assume that's ln of u, so the derivative is 1 over u times u prime. So here's my 1 over u, the derivative of u is negative 1. Now they want us to find the slope when x is negative 1, so I'm going to plug in a negative 1 and I'll get negative a half, which matched up with b. The next one is number 22. 22, let me get to the question. Says a particle moves along the x-axis so that the time is greater than or equal to 0, and they give the acceleration. So the first thing I did was integrated the acceleration to get the velocity function. And then they tell me the position of the particle is 10 at time 0. The position of the particle is 20 when t is 1. They want us to find the velocity at t equals 0. So there are a couple steps here. So the first thing I did is if I use the fundamental theorem of calculus and integrate the velocity function, I will get the position function evaluated from 0 to 1. So I know that's going to be equal to, when I integrate, the position at 1 minus the position at 0. So we're using that net change theorem. They gave us the position at 1, they gave us the position at 0, and we can integrate this velocity function. Now c is a constant, so when you integrate it, you'll get c times t, and then we'll evaluate that using the fundamental theorem from 0 to 1. So when we plug that in, we'll be able to solve and find out the c value. And then they ask us the velocity function at time 0, so we can give that answer as 6, which was answer D. Another way to do it is if you integrated to get the velocity function, and then you integrate it again to find the position function. Now if you do it that way, you're going to have 2 c values, which is fine. Then you'll have to use the 2 ordered pairs, 0, 10, and 120, to find your C1 and C2. And we wanted the C1 value, which would be the velocity at time 0. And then the last one is number 25. And 25 is giving us this definition of the derivative. So they're giving us the limit as h approaches 0 of f of x plus h minus f of x all over h. So the actual function that we're plugging in is 1 over e to the x, or e to the negative x, and we're finding that when x is 1. So when we plug that in, we will get this in our definition of the derivative, which is what they gave us in the problem. So I know the function is e to the negative x. They're asking us what the derivative is. Using shortcuts, it's negative e to the negative x. And at x equal 1, the answer will be negative 1 over e, which is answer B. So what I would suggest that you do on one like that is to actually write down the definition of the derivative, and then you can compare it to what they gave you. So limit as h approaches 0 of f of x plus h minus f of x all over h, and then try to figure out what your function would be and what the x value is plugged in. Okay, I will continue to do videos on questions that you have, so just make sure you email me with questions. Have a great day.